So I have split this into two parts. Part one is features of 5G and part two is cellular IoT. Yeah, this is in brief about my university and college. I wish to say I will not spend much time because I have been already late. Padma Shri Dr. Karshan Bhai Patel has established this university as a chairman of Nirma Limited Company. He is the president of Nirma Education and Research Foundation and Nirma University. The Padma Shri Award has been awarded in the year 2010. Uh, then few more awards are also there. The Lifetime Achievement Award in 2009, Sardar Vallabhbhai Patel Ishwa Pratibha Award in 2009, honorary delete, then Ernst and Young Lifetime Achievement Award, honorary doctorate from of Human Status by FAU USA, and Gujarat Businessman Award in 1998, Udyog Ratna Award, and few more. This is a look of our one block of our Institute of Technology. This is A block. We are having 5 blocks over here, A, B, C, D, and N block, which is a high-rise building, of course. This is a brief about my campus. Nirma University has various institutes like Institute of Technology, Institute of Management, Pharmacy, Science, Law, Architectures, Commerce, and DoD also, and few centers also. In BTech, the intake is 120 in Electronics and Communication Engineering. We have 2 MTech regular courses. The strength is 18 each. We have MTech by research program also and doctorate program. So few photographs of the courses we have organized for various experts or community. This is MATLAB for engineers, image processing and application for the scientists of SEC ISRO. I am over here. The second one. This is another simulation of wireless communication systems in 2013. There are almost 100 participants were there. This is a team of Goa Engineering College who have addressed this one. Recently, before lockdown, we have organized 2 days seminar on 5G wireless technology. It was funded by Kuch Coster BST. This was inaugurated by eminent academician Professor Ajit Kumar Chaturvedi. He is the director of IIT Roorkee. Now I will start my sessions. Okay, so this is outline of my talk. Prerequisite to understand about 5G and IoT, wireless and cellular communications. You should be having fundamentals of wireless and cellular communications. Introduction of 5G, evolution in mobile communication from first generation to fourth generation, and evolution beyond 4G, that is 3GPP release 10 onwards. Prerequisite classification of wireless feeding channels. We must be aware about the delay spread, because when we talk about high speed communications or high data rate communication, the ISI will be the biggest hurdle. So what exactly ISI is and how we can remove it. Second is the Doppler spread. When we talk about high mobility, when we talk about communication in aircraft or with high-speed drone, of course, the Doppler is the biggest enemy for that. So the Doppler will create hurdle in wireless communication or connectivity. Then multi-antenna systems that are used nowadays in the standards like LTE and WiMAX. CMOS system, single input and multiple output. We are using different combining schemes like MRC, GC, and selection combining. We are using all these things in standards also, LTE standards. Then a multi-input single output. We have two transmission scheme for MISO. One is transmit beamforming and another is space-time coding. Multiple input, multiple output, very popular buzzword nowadays. Massive MIMO is there, of course. Obviously, multi-input, multi-output means more transmit and more receive antennas. MIMO system with diversity gain and spatial multiplexing gain. Spatial multiplexing gain. Transmission scheme is transmit beam forming and space-time coding. Reception schemes such as coherent and non-coherent. You know that in coherent detections, we require the channel knowledge at the receiver side. So we need to estimate the channel at the receiver. And in non-coherent, the channel knowledge is not required. So according to the conditions like complexity of channel estimation is high and high power is required, then of course you cannot go for coherent, you can go for non-coherent detections. Estimation of channel and complexity at the receiver will play an important role. We must know about this. And finally, MIMO, OFDM, and features of LTE. If you know about all these things, this session will be an interesting one for you. Now, friends, quality of service, any communication systems, just a minute. Of service, you know, any communication system, we talk about simple binary communication system from transmitter and receiver. We are having we have having experiments in our laboratory also. So how the very first thing is quality of service. How will you measure the quality of the communication system that you are using? So for that, we need to understand about some performance parameters. So very first thing is probability of error. As you know, it is a function of SNR. It will indicate how reliable the system is. Probability of outage has a connection with coverage of the cellular communication systems. The data rate, you know that the main objective of 5G is to go for a high data rate. So the data rate is one of the important thing, and for that we are having a very good support of Shannon's equations. C is equal to B log 1 plus SNR. So if you wish to increase the data rate, you need to increase the capacity of the channel, which is equal to C. The fourth one is the spectrum efficiency. You know, friends, the spectrum is restricted. It's not infinite. And now the usage of spectrum is very high. It's become very expensive nowadays. So we need to utilize the spectrum efficiently. So spectrum efficiency is measured in terms of bits per second per hertz or bits per second per hertz per unit area. Energy efficiency. Till now, there was no problem of energy. We can install any number of base stations. But nowadays, as we are going for 5G, the number of base station in certain areas are higher than number of users. So many base stations are required. So it consumes a lot of energy. So we need to think about efficiency, energy efficiency that is measured in terms of bit per joule. The delay or the latency is very important when we have a two-way response, autonomous driving, suppose, right? So delay must be very low. So it mostly affect the RAN part of radio access network of the base stations, which should not occupy much time to initiate a call and during the real-time data communication also. Price is the most important thing. If it is not affordable by a common man, it will be a useless technique. So lower price and complexity. MBMS operation in 5G, I hope many of you may be aware about it. Its MBMS is for multimedia, broadcast and multicast services. Now, at some spot, few users want to see the same channel, then the cellular communication base station should not allocate different channels to all the users, right? But all the users will use the same channel and receive the thing. It is in the broadcast mode. So like if the game is going on in the ground, and suppose all in the audience, the people want to see the match on their mobile screen, then MBMS operation is to be activated, and the resources of the cellular may be saved. So 5G improves the key performance metrics such as delay, reliability, speed, mobility, and spectrum usage. Now there are few questions, right? And at least we should be aware about the answers of this. How can we increase the SNR or coverage in feeding channels? So Four answer I have. You may have other answers also. You can write down at your end. Introducing diversity techniques in time, frequency, and space. Mostly we are interested in space due to advantage over time and frequencies. And so we have gone for CMO, MISO, and multi-antenna systems. So which will increase the SNR or coverage. The second technique could be introducing advanced error control coding schemes such as turbo codes, which are used in 4G standards, and LDPC codes which are used in 5G standards. The third technique would be introducing tactics to increase SINR. Friends, earlier we were talking about SNR, but nowadays SNR is not important, but SINR is important, or rather I would say SIR, signal to interference ratio. Noise, because nowadays due to very high quality of semiconductor material, the thermal noise, the Gaussian noise is less effective. But the major source of noise is interference from the undesired users. So SINR will play an important role. So for improving the SINR, you can use transmit beamforming, which can focus the energy at a particular spot. A heterogeneous network, that is headnets. You can use small cells also. In LTE Advanced, of course, in 4G it has been introduced, and 3GPP next versions, I mean to say, the improvement in that has been done. So whenever the hotspot is there, more number of users are there, we can accommodate a small cell over there which can serve a specific area. Interference coordination, that is to be taken care at the transmitter site, that is the base station site, and interference cancellation is to be done at the user site. The fourth technique is why not to use a hybrid network such as a terrestrial and satellite, because the coverage of terrestrial network is restricted while the coverage of satellite is very high. So whenever one is there and the other is not there, it can be complementary one. The second is Wi-Fi and cellular. This combination is very important because in the 5G, one important term is there, data offloading. Data offloading, of course, when the term will come, I will go in depth of it. Generally, when we are in the open space, we are using the internet connection of cellular operators, base stations. From that, we are using internet access. But when you enter in your office or the Wi-Fi region, maybe airport or railway stations or somewhere where the Wi-Fi is available, automatically your internet connection will be switched from cellular to Wi-Fi. The advantages are that, of course, the expensive cellular resources may be free, it can be utilized by others, and you can use the Wi-Fi which is on the free band. So friends, by using all these things, you can increase the coverage or increase the SNR. The second question is coming, it is related to 5G, is how can we increase the data rate? So for that, we will take the support of Shannon's equation, C is equal to B log 1 plus SINR. Diversity, because you can see there are two terms. One is bandwidth, second is SINR. If you increase these two terms, you can increase the capacity of the channel. As a result, you can increase the data rate. Now, SINR or SNR can be increased by all the scheme, the diversity schemes, right? We have seen that it increases SNR. Beam forming schemes, SINR can be increased. Interference cancellation, SINR can be increased. This is at the user side. Interference coordination, which is supposed to be done at the transmitter, meaning the base station side. That means two base stations must be connected and they must be aware of one user, a specific user. And the resource allocation must be such that the interference the user due to this 2 E node B should not be there. Friends, so this is about increasing SNR or SINR, a spatial multiplexing single user MIMO, SU MIMO, where in this equations you have the term which is multiplied, which is N. N into N, N into B into log, where N indicates the lower of antenna available at the transmitter and the receiver. So you just find out the lower number of antenna from transmitter or receiver, and you can increase the data rate at that time. That's really interesting thing. A single user MIMO I am talking about, right? If you have 5 antennas at the transmitter and 4 antennas at the receiver, you can increase the data rate 4 times. So that is the advantage of spatial multiplexing. Adaptive modulation and coding, AMC, we are fully using this AMC schemes. In LTE Advanced, we have used 64 QAM, and now in 5G, we are using 1024 QAM. So adaptive modulation and error control coding. Along with that, we are using scheduling. Schedule the user equipment where the SNR is higher. So automatically the SNR will be increased. And last, and because it is expensive, you can increase the bandwidth to increase the data rate, of course. But you know, this is very expensive. And another thing is that if you increase the bandwidth and if you're transmitting a high data rate symbol, then ISI will be there. To fight against the ISI, we are using OFDM, correct, to reduce the ISI. So this is about the solution of a second question. The third question, how can we increase the number of users? Because that is the third requirement of 5G. So one hint is that reducing cell radius. If we make the cell size smaller, then we can reuse the resources, right? Increasing the reuse of resources, as a result, you can increase the number of users. But of course, over here, you need to take care about interference from adjacent cell that you need to take care. The second is heterogeneous network. Suppose some hotspot has been formed where many people have gathered, right? And particular spot becomes hotspot. So what we can do, we can install a small base station over there, which will cover that area, and that is a part of HETNET. So hybrid configurations of a macro cell, which is a high power cell with a small cell. Data offloading can increase number of users. As I told you, as soon as you enter the Wi-Fi zone, the cellular resources may be free. It may be used by some other users, right? And the Wi-Fi region, in the Wi-Fi region, the Wi-Fi access point will serve you. Using MIMO, we have various configuration of MIMO. We have SU MIMO, single user MIMO that we have seen. Multi-user MIMO in the sense, suppose I'm talking about M cross N system. M cross N system, then M transmit antennas are available at E and B, E node B, and N antennas are there at the receiver side. In single user MIMO, these N antennas are there with one user only, but in a multi-user MIMO, each antenna is corresponding to one user. So that is the advantage of multi-user MIMO. So yes, multi-user MIMO in the sense at the receiver side, one antenna meaning one user. That means on the same resources, with the same resources, that is same number, same spectrum, and same time, you can serve end user without any interference at all. That is the advantage of MU MIMO. Network MIMO in the sense 2 in node B will serve the one user. Mostly the user is there at the cell edge where the coverage is very low. So 2 in node B will cooperate and serve that user. That is the network MIMO. Using inter-cell interference coordination techniques, as I told you, coordination between base stations for cell edge users, COM techniques, that is the relays 11 and 12 of 3GPP, coordinated multi-point transmit receive. Now, just go through this evolution. I will not spend much time for it. First generation, which was analog, which was using FDMA, the data rate that could be achieved with the first generation is 14.4 kbps. The name of the system is EMS. This was implemented in US. After that, the second generation, along with voice, the SMS facility is also possible. So this is digital, which is using circuit switching. Bandwidth allocated to user is 200 kilohertz, and it is using FDD, means uplink and downlink frequencies are separate. Now, this standard has been implemented in two ways. This IS-95, which is using CDMA, which is implemented in USA, which is very much compatible with the analog one. And GSM, this is second generation, which is implemented in Europe and the rest of the countries in the world, except USA. It's a very popular scheme, GSM. 9.6 kbps data rate you can achieve, and multiple access TDMA or FDMA you can use. Now the requirement, see the evaluation, meaning the requirement from the people and how we can comply it. So 2.5G, which is just enhancement of 2G, which is for internet connections or voice plus SMS plus data communication. For internet communications, this 2G standard has been enhanced as 2.5G. The name of that is GPRS. The rate that you can achieve is 40 kbps in 1990. This is evolved as IS-95B. This was in US. Packet switching, because the data communication is used, it is added in 2G. Further, it is enhanced by 2.75G. The name of that is H, and the data rate that could be achieved is 120 kbps. And then the International Telecommunication Union, the international body, has announced the IMT 2000 requirements. You know, now we need a standard which can give us a 2 Mbps data rate. This much a data rate I want now. This is the announcement from International Telecommunication Union. Name is IMT 2000. So people have worked on that, and ultimately the 3G standard has come out. It was found out that no more TDMA or FDMA can take this load of giving this much data rate. So, and ultimately it was checked that CDMA standard can be used. CDMA multiple access. So WCDMA, which is used, this project is known as 3GPP, and which has led us towards the 5G communications. In the USA, this was evolved, IS-95B was evolved as CDMA 2000 standard, IS-95C, and this project, namely 3GPP2, has gone ahead with this particular with particular specifications. But what happens when the standard was introduced and executed in the market, it could give us only 384 kbps in the 5 megahertz bandwidth. It was expected that it will give us 2 Mbps, but it has given us only 384. So I would say 3G has been failed. 3G failed because if you try to increase the data rate after increasing the bandwidth 5 to 6 megahertz or 7 megahertz or even higher than that, the receiver will be very complex. Receiver in the sense user equipment will be very complex, so it cannot be affordable. So enhancement has been done in 3G by 3.5G, namely HSPA, where adaptive modulation is introduced. Adaptive modulation in the sense, according to the SNR at the receiver, the transmitter will change the modulation scheme. If the receiver SNR is very high, then of course transmitter can use the higher order modulation scheme, and it can increase the data rate without increasing the bandwidth. Further, it is evolved as HSPA Plus, where MIMO, multi-antenna systems have been installed, and the data rate that we could achieve is 1 to 3 Mbps. Now the process is still going on, and LTE has come, that is long-term evolution. Actually, this is LTE is known as 3.9G, and sometime it is sold at 4G also. So 3.9G and 4G, I would say LTE is coming in both. So this is voice over IP. Now no more circuit switching is. We are using packet switching for audio communication also. And this LTE could satisfy the IMT 2000 requirement. The bandwidth used is 20 megahertz, 326 Mbps instead of 2 Mbps could be achieved if you are using 4 cross 4 system. And the latency is reduced to 10 milliseconds, which is quite less. So LTE is very much supportive, but the most important change in LTE is OFDMA. Multiple access is the duct. In cellular communications, to increase or to improve the parameters, the very first thing we need to target is multiple access scheme. How the inode B will serve all the users. That's the most important thing. So OFDMA is used in LTE. At that particular time, the ITU has announced further requirements, IMT advanced requirement. It is known as IMT advanced requirement and said, no, no, now 2 Mbps is not enough. You should go for 1 Gbps downlink and 500 Mbps uplink data rate. Please try to search for this standard. And now LTE has been, enhanced by LTE advanced, that is release 10. This is my true 4G, right, which can give us this. And now I am coming from 5G. And after IMT Advanced, IMT 2020 requirements and 5G vision has come. Now, what is the requirement of IMT 2020? These three buzzwords are there as you go ahead in this short-term course. You will come across these three words again and again: EMBP, MMTC, URLLC. These three are the main target of 5G vision, and of course, the itself is very clear: high data rate with wider range of data rate. So, of course, the blue text shows that high data rate. I want to increase the data rate. I want to go for high data rate. Uh, but the red text you can also see. This is not smooth or not easy to achieve. You can increase the data rate, fine. You can increase the speed, but then to work with a wider range, that means lower rate to higher range is very tough, right? So high data rate I want to achieve, but at the same time, because like IoT, I think all of you have heard about IoT. If you think about applications of IoT in agriculture, where I want to check the humidity and the water level or temperature of the soil, right? So a small sensor has been kept. So this sensor will communicate with a very lower data rate. I don't want higher data rate, that is video streaming, right? So 5G should work with a very wide range, and it is very tough, right? You can teach the students of same class, but it is very tough to teach the students of various classes. Massive machine type communication, MMTC, large number of connections. Nowadays, the number of sensors which are connected in the network is higher than the population of the world. Large number of connections, right? Many SIM cards you require, many connections are required, and you need to take care about it. And the third one is lister delay or URLLC, autonomous driving or remote surgery, medical surgeries to be done. So delay must be list. Okay, ideally it must be zero almost. So to comply these three things, some specification you can just go through it: 20 Gbps peak data rate, 1 Gbps at least. The speed of the receiver or the user equipment can be 500 kilometers per hour. Bullet train you can think about. The latency is to be in between 1 to 5 milliseconds. Connection devices are 100 times more than the current devices with different requirements. Agriculture sensors, as I told you, very lower data rate, but some drone, okay, for video streaming, required data rate with very high value. Compatibility with GSM 3G, LTE, LTE Advanced, and Wi-Fi. The existing standards, the available existing standard, your 5G must be compatible with all this. 1000 times improved on network and energy efficiency. because this much energy, the actual energy we cannot provide. So we need to improve the efficiency of it. 10 lakhs per kilometer square connection density, low power consumption, 99.999 percentage reliability within 1 millisecond latency, vehicle to vehicle communication, and vehicle to network communications. Evolution in mobile communication, evolution up to 4G. This is my perception actually. I hope I am audible. I can't see the number of participants. Am I audible?
Yes, sir, you are audible.
Okay, okay, madam. Thank you. Evolution, this is my perception. Evolution up to 4G is like upgradation in a structure of a building to accommodate more people with more comfort. That is an objective of 4G, I say. You make a high-rise building for a BHK house, right? More facilities are there, excellent facilities there. But 5G is like a development of a colony or a township where various facilities are provided to different class of people according to their requirements. It's a colony, 1 BHK. That's our should also be there for a common man who do not want to afford much, but they want to stay. So the 5G is something like this. Okay, another questions I think many of you have come across this. Are these applications of IoT automatic water level reading in river? I just want to give a small example for this. Few years back, there was a flood in Surat city. There was not a heavy rain in Surat city, even though the dam side, all of a sudden the water level increased, and the authority at that moment had to open the gate because excessive water can damage the dam. They were not aware of it from where the water has come. Actually, on the upper side, heavy raining was there, and due to that, the water was collected on the basin part, which is in Surat city. So can we predict about this so that this kind of condition may not happen? Because half of the Surat city was sunk at that moment due to flood. So what we can do, there are many bridges on that the vehicles are going on throughout the path of the river. Can we put a small GSM module, a GSM receiver? The modules are available. I think the students are doing project with GSM module, which is sensor which can sense the height of the water, okay, in the river, and the control station can fire an SMS to all these users which are placed below the bridge. In the rainy seasons, after half an hour or some time interval, the SMS will be fired from control stations to all the users. Users will read the automatically through the sensors. The water level is measured, and through written SMS, it will go to the control stations. And control station will get the informations about the water level or rise in water level at all the bridges, and then calculate that after some time the total water accumulated in Surat city will be something like this, and accordingly the gate can be opened. In Iowa University in USA, this project has been successfully implemented. In India, we want this kind of project more and more because many rivers are flowing out of the danger in monsoon. So can we say this is applications of IoT? We don't want any advanced thing which is available in 5G. Just a GSM is able to do it. I will talk about cellular standards, right, in part 2, where GSM can also be used to serve the IoT purposes. The second application can be automatic energy meter reading. At this moment at our house, the person from electricity company has come and read the meter. Instead of that, can we put a small GSM module to the energy meter, and from the control station, SMS can be fired to read that, to access the readings and send it to the control station. Control station will deliver the bill. Simple. This is some advanced applications. Video streaming of affected areas through drones for disaster management or surveillance. Almost 50 lakhs rupees project we have proposed in BST for this. Actually, it's drone communications. Just now in the monsoon, due to heavy flood, you have seen the animals, right, which were flowing along with the water in the rivers, or some communal riots has taken place, and I want to survey it. So what you can do, you can just send a drone over there. Drone usually till day what is happening, the drone will capture the image or record the video, then the drone will come back, and from that the video can be received. But can a real-time video communication is possible? The drone will go to the spot, capture the image or the video, and deliver it to the cellular network itself. So that the disaster management place, the people can check the conditions and then respond it. So these are applications of IoT. If vision of 5G is to provide environment in which sensors, appliances, cars, drones will communicate with each other via cellular network. Evolution towards 5G. These are the terminologies or list of some keywords which are used in 5G, or again and again they are referred in 3GPP releases. Just now 3GPP releases 17 is about to announce, and it is about to come. These kinds of words are continuously coming, and enhancement in each one has been done. So just I will, because the time will not permit me to access all carrier aggregations, more than one carrier, that is the feature of LTE Advanced. Enhance or higher order MIMO. You can increase number of antennas, but there are restrictions on this. Just now in the morning session, we have had a very nice session on antenna design. MIMO system, we have a restriction of antennas because the antenna must be far apart of some distance. You cannot place it closer, otherwise correlation will occur. Correlated channel will be harmful to you. So multiple antennas I want to implement at the base station as well as at the user. So LTE 4x4 and LTE Advanced we have 8x8, and now with millimeter wave and massive MIMO we are going for 100 or thousands antenna at the transmitter and 1,000 antenna at the receivers. Heterogeneous network, continuous enhancement is there in headnets. The small cell, the femtocell, which can be placed at our home. Then the femtocell, then eco that you can install in the mall site, right? So how you can improvement, how you can do the improvement in that. Enhanced multimedia broadcast multicast services, MPMS. Just now I have talked about it. Relaying to increase the coverage of 5G, self-organized network SON, which has a very important role in HeadNet, because in femtocell, whenever you want to make a establish or a setup a small E node B at your home, right? You switch it on, but on which frequency it should work. It should not interfere with the existing terrestrial or E node B under which the area has come. So self-organized network. Enhancement in inter-cell interference coordination. This is a continuous process. Coordinated multi-point transmission. A true E node B can coordinate with each other and serve the user so that interference can be reduced. Because as I told you, to remember now, SNR is no more important for me. SIR is important for me. Interference is too high. So how can we reduce this? Energy saving. I will show you some slide about that. D2D communications, device to device communication, where eNode can be free. If the two users are very close, then there is no need to make eNode be a mean in between two. Directly they can communicate. Data offloading, just now I have explained about it. When you have LTE and Wi-Fi, when you enter from LTE to Wi-Fi coverage, you will be served by the Wi-Fi unit. But this is automatic. This should be automatic in data offloading. Just now, whenever you are entering from a terrestrial coverage or cellular coverage to a Wi-Fi, you need to authenticate it, right? You need to authenticate in the sense it's not a real time. There will be a break in between, but in data offloading, this break is not there at all. Then we have a 3D MIMO. Just now we are using 2D MIMO. With 3D MIMO, which is a combination of massive MIMO and wave communication. Along with that, you can implement 3D MIMO. You can increase number of users. You can reduce the interference with the help of 3D MIMO. Machine type communication or machine to machine communications, right? This IoT. Mostly machine type communication is very much useful in IoT. It's vehicle to vehicle communication, B2B. 14 more terms are there: Internet of Things, some ancient critical applications, remote medical surgery. It should be a very real time. Body area network. The parameters of a human body can be measured by a sensor, and it will be communicated to a server. Hybrid beamforming. Those who are aware about beamforming in multiple transmit antennas. We are having analog beamforming as well as digital beamforming. Both are having pros and cons, so we are using hybrid beamforming. Mobile relays in high-speed railways. If you want to give connectivity in high-speed railways, then a normal mobile cannot work because the frequent handoff will not allow us to communicate, right? So that could be a relay on the above the coach, and the users inside the coach will be connected with the relay, which is above the coach. So the relay will work as node B for all the users which are available in the coach, right? And this relay will communicate with the ground stations. On the ground, the node B is there. So for ground node B, this relay will be the user equipment, but for the train, the relay will be the node B, and all the users are user equipments. Non-orthogonal multiple access. As I told you, the multiple access has very important role in improvement or evolution of these cellular standards. Till now, all these multiple access schemes were orthogonal schemes, either TDMA or CDMA or OFDMA. All are orthogonal. But now, non-orthogonal multiple access you need to implement if you want to increase number of users. So that is again important term. And based on that, the new radio standard, of course, it is coming. NR standard has come out. Then millimeter wave communication, just we are increasing the bandwidth or the carrier frequency 3 to 300 gigahertz. The issues, you know, that ISI and other things, LOS, absorption in the air, many issues are there. And as I told you in 5G, if you trace some area, in that particular area, number of base stations are more than number of users. Massive MIMO, industrial IoT or Industry 4.0 standard, which is completely devoted to the automation in the industry. New radio standards, cognitive radio, yes, spectrum's scarcity. Now the spectrum, of course, if we are using wave, then we are having a wide spectrum. But in the microwave, we have a range now. We cannot go beyond that. So in that, the spectrum sensing, I think many of you may be aware about it. In cognitive radio, I wish to sense the spectrum, and if the spectrum is free, the licensed spectrum is free, the unlicensed user can use it, but it is all up to the uh, occupancy of the primary users, the licensed user. If the band is free, the secondary or unlicensed user can use it. But as soon as the primary user want to use it, the secondary user will uh, take the another band. So that's cognitive radio is part of 5G. Unmanned air vehicle, UAV or drone communication with cellular networks. Just now I have given one example of it. During calamities or communal riots, I want uh, I want to view the real-time situations. You can use this one. Autonomous driverless cars, hybrid network using cellular and satellite. We have seen the hybrid network between terrestrial and Wi-Fi or cellular and Wi-Fi. The another hybrid is in between satellite and cellular because the pros and cons of both are not same. The satellite has a wide coverage, but it is expensive. Cellular has not so wide coverage, right? And it is cheap. So obviously you can accommodate both. So we are planning about making a user equipment which is compatible with both satellite as well as cellular. So accordingly, it can switch it. So friends, these are the list of the terms which are mostly used in 5G. Now, carrier aggregation, I don't want to go in depth because many of you are aware about LTE and LTE Advanced. So usually one carrier will serve one user and the bandwidth is 20 megahertz. Now, 5 carriers can be allocated to one user and you know the rate can be increased 5 times. 5 carriers are aggregated in LTE Advanced, but in the next releases, 72 sub-carriers can be accommodated to one user. So you can see over here this mobile phone. These all slides I've taken from 3GPP website. Uh, this mobile wants to use 20 megahertz bandwidth only. This this laptop wants to use 40 megahertz, so 2 carrier, and this want to use all the 5 sub-carriers. Then next is MIMO system. A wireless communication system is used in 3 different possible ways: transmit, receive diversity, beamforming, spatial multiplexing, and codebook-based precoding is used for beamforming and spatial multiplexing. I hope you know about it. I will skip it. This is LTE Advanced. Heterogeneous network to meet high traffic and data rate demands. The key options to expand network capacity are by 3 ways you can do it. These are the 3 ways, 1, 2, and 3. The first is to improving the macro layer or high power inode beam. I'm just increasing the power and coverage of this. This is one way, right? The second way is that densifying the macro layers. You accommodate more and more inode beam this. But of course over here interference will increase and over here radiation will increase. This is the third where I will complement the area of this with the help of small cell. This is a small cell and I will, serve this many users in these small cells. So this is heterogeneous network at next. Well, this is a small cell. Over here, all these base stations are of same type. Over here it is high power, over here it is low power. So complementing this one. Heterogeneous deployments is a K tires, right? This is a 3 tier when the macro cell basic outdoor unit that you are watching in the across the highways on the high-rise building, high power inode beam, and EcoCell, which is available in the mall and others market site, Emtocell, which is a very low power or home inode base, and the power allocation transmit power for a macro cell is 46 dBm, EcoCell lower. If M2, which is used in house, is even lower, relay can be used and RRH can be used. This is macro, Pico, and M2. Technical challenges. It's very easy to say that I just want to implement a small cell, but whenever you implement, execute it, you will see this kind of problems. Interference from a high power cell to the lower power cell. We will see about this. Cell for organizations. As I told you, home inode be. You are going at your home from the office. The family members have entered the home. They have just switched on the small inode be. Now on which frequency it should be operated? Because that house is already under the coverage of high power macro cell, I have to say. So interference should not be there. Backhauling is the main issue. Handover is again one issue. This is a relay. Relay will extend the range. Okay, this is inode B. This user equipment is far away. This unit will work as a relay. So it will increase the cell edge throughput and coverage in new areas. Relay, yes, there are some use cases of relays. This is a multi-hop relay, relay 1, relay 2, and user. So this inode B can serve this users by using 2 relay. Then the B is if within a building. This is a building, and inside users are there, right? So coverage may not be possible inside the building due to walls and others. So we can put a small relay node over here, which will relay it. C portion is a cell edge users, extend the coverage, right? Few more use cases of relay. Underground areas like trains and others, you can put a relay over here. Valleys, okay, located within a building, in between two buildings. And mobile relay node is used in high-speed trains, correct? So the relay. Mobile relays in high-speed trains, just now I have talked. I will not go in depth of it. Just 115. Got it. Okay, I will skip this. Interference in headnets, heterogeneous network. What happened exactly? The first issue is interference. Just see over here. This is a macro cell. This is a pico cell. The user is very close to pico cell. So actually, uh, uh, in a real scenario, this must be connected with this pico cell. But the receive signal strength from macro cell is higher than the strength of the pico cell. You know how the handset will be connected with the base stations. Whichever from where it will be getting the high power, the user will try to connect with that E node B. So even if it is far away, the received signal strength over here is high. This is very close E node B, but the received power will be very low from here, so signal strength will be very low. As a result, this handset will try to connect with the with this macro cell. And of course, I don't want that. The reason is that during uplink, the handset has to transmit very high power to reach the signals over here compared to over here. But the selection of the node B from handset will be based on the downlink power received. Okay, not on uplink. So this, I mean to say over here, the problem is that I want this user equipment to be connected with this, but actually it will be connected with this. So in this case, I can, this is imbalance of downlink and uplink, I would say. This is called downlink uplink imbalance. So in this case, I will add some offset with the received SNR from pico cell E node B. For example, from here I am getting 5 dB SNR. From here I am receiving 3 dB SNR. Then offset of 3 dB, constant 3 dB offset has been added. So 3 plus 3 equal to 6 dB, over here 5 dB. So obviously the SNR received over here will be higher, it will be connected with this. Right. So this is called cell extension. Cell inefficiency. Some bias is added, and it's called cell range expansion. But of course, the problem is there that interference of this will also be there. So there are techniques which will remove the interference from this. So that is the next technique is coordinated multi-point transmission and receiver. As I told you, there are two techniques: joint processing and coordinated scheduling or beamforming. Joint processing in the sense this user is available at the cell edge. From both node B, the signal, the received signal strength is very low. As a result, it cannot be served well. But over here, during the COM, both E node B will cooperate, will coordinate, and both will give the same resource to these users. So actually this user is receiving from both the E node B the same information. As a result, the received SNR will increase and there is an improvement in the PER. So this is all called, this is something amazing, because one user will be connected always with one node B. But over here, this user is connected with both the node Bs. As a result, the signal strength will improve. This is coordinated scheduling or beam forming. Two users are there, both are there on the cell edge, right? Now, if the same resources are given to both the users, they may interfere. So over here also the cooperation between two node is there, such that the resources allocated to this user equipment is orthogonal to the resource allocated to this. Friends, it's very easy to say, but for that there should be a real-time communications between two node B, which usually is not there in case of 2G, 3G, right? This two in node B must be aware that okay, I am serving this user equipment with this resource. And this is a diagram of it. The same thing, joint processing. This user will be served by this two. This is a dynamic selection. This is one more. This is coordinated beamforming in the sense this inode B will serve this user with some resources, and orthogonal resources are there with the second user by the second inode B. And dynamic selections, if it is in this zone, this will be served by this. If it is over here, it will be served by this. Friends, energy saving is one more aspect, as I told you, because a lot of energy has been consumed by base station nowadays. So one technique is operation and management predefined policies. You know, our website or some power plant is under maintenance for after some time, after some days. In a similar way, if we follow this schedule, I think we can save the energy. This is the office area, this is shopping area, house, okay. One macro cell is there which will serve all this wider area at some time. In the morning 8 o'clock, this is a diagram from USA, so at morning 8 o'clock, the office region is active. So a small cell will be active over here. It will be switched on at 8 a.m. The cell base station or inode B over here will be active at 8 a.m. only. At 3 p.m., this shopping area will also be active. So in this time interval, this 3 inode B will be active, but at night 9, once again this 2 will go to off state and only 1 will be active. It is how you can save the energy. The second is compensating cell A. You can see a few cells over here, A, B, C, D, E, F, right? In a peak time, all are active, but night time, the B, C, D, E, F can go to off state, and the coverage of cell A can be increased by increasing the small power, because number of users are not too many in each of these cells. So you can just extend the coverage of cell A and you can serve all the users. D2D communication, it allows communication between two devices without the participation of the base station. It is surprising. Proximity means closer devices can directly communicate with each other by establishing a direct links. Direct links, no channels to be received from the inode B. Directly to inode B, if two user equipments, if they are closer, they can start communications. There are many advantages if you can do it. Due to the small distance between D2D users, it supports power saving, improves energy efficiency, throughput, and delay. Effectively offload traffic because now your inode B will be free. Directly you are communicating with the user equipment. These cases are use cases of D2D are public safety services. On the highway, some accident has occurred. Just you turn on the handset, the adjacent person will receive the call, even if there is no coverage at all. Cellular offloading, just now we have seen V2V communication. In all this case, D2D will help us, but how can we do it? That is a big question. There are some category of D2D communications. Suppose the user equipment is far away from the inode B or base station, then the relay can help it, right? This source can transmit the information to relay and relay will transmit it to base station. So cell edge users where poor coverage is there, you can use this D2D communication. D2D means source to relay over here. The second category is there source to destination, but the facility will be given by base station. Base station will contact both, and this base station will instruct the source and destination to use some channel for communications. But control station, the communication is entirely managed by the base stations. Of course, these two will talk with each other, but it will be controlled by base station. Category 3, where relay will play a role instead of the base stations. This relay will work as a base stations and it will command source and destination both. So control of the base station is missing over here. And the last one, which is very important, no need of base station at all. Directly this you can. Many survey articles and good articles are available, but if we can simulate the systems, that will be an excellent task. Restrictions of D2D communication, feasibility of D2D communication is determined by the distance restrictions. Both must be closer. If they are away, then if they are mobile and at one moment they are closer, but after some time if they are away, the communication will be open. Interference may be there because two D2D users, one connection, the second, okay, both are very closer, both are not aware of it. So actually there are two pairs. One pair is active over here, another pair is active over here, and both are using the same resources. So interference may occur. We need to take care about it. Prior to transmission, a device discovery is required, which is very expensive. Peer discovery and the security is again one more issue. Data offloading, now I don't want to repeat, just go through the slide. Cellular networks are under pressure to deal with today's unprecedented data overload. Major investments in the radio access networks and the core infrastructure. Upgrading the RN is very expensive. Scared license spectrum hinders the RAN enhancement. Spectrum is very expensive, right? That's why adding traffic beyond a certain limit degrades the performance and the QoS due to congestion and the overload at RAN level, right? Due to all these reasons, so unfortunately, this trend will be accelerated in future due to the predicted mobile data explosion. So our base stations are not able to serve this many users with this much required. I hope I am audible well.
Yes, sir.
Okay, okay. So the alternative methods to mitigate the pressure on the cellular network is mobile operators solve this contingency by throttling connection speed and capping the data usage. Throttling connection means you cannot uh, go beyond this data rate. Up to this you can enjoy, but you cannot go more than that. And second is capping the data usage. Every day you can use 1 GB data. After that, you will not be served. However, this practice will negatively affect the customer satisfactions. Mobile data offloading is a low-cost solution. Now the offloading is starting to use the unused bandwidth across different wireless technologies because Wi-Fi, Bluetooth, mostly Wi-Fi because it is having a higher spectrum. The use of a complementary wireless technology to transfer data originally targeted for the cellular network 3GPP in release 11 and 12 accommodated, right? So friends, it's very important to make a headset which is not compatible with Wi-Fi and LTE, but the switching operation can occur instantly in between that. So benefits of this, relieving the infrastructure network load, shifting data to a complementary wireless technology that is Wi-Fi, increasing the overall throughput because while Wi-Fi is using the wired connections, after access point everything is wired, I mean to say. So the internet speed can be higher, reducing content delivery time, extending of network coverage, increasing network availability, better energy efficiency. But please remember that Wi-Fi is not a cellular network, meaning handoff is not possible. In the restricted area, you can have the mobility, but as soon as you cross the coverage, you will be helpless. So at that moment, the cellular network must take a charge of users. Then and then connectivity will be maintained, otherwise not. Challenges, infrastructure coordination, mobility of users, service continuity, pricing, because cellular operators do not want that their customers will go to Wi-Fi. because nowadays when the Wi-Fi coverage are there, we are using Wi-Fi, and the cellular operators may not earn anything from Wi-Fi. Of course, they are not so much interested for it. Lack of standards. There is no standard for data offloading. 3D MIMO and 2D MIMO. Okay, I want to show you in diagrams. So this time can be used. This is 2D MIMO. See what happens. This is the base stations. These two users are there. So actually, nowadays in 2D MIMO, the beam is there with azimuth. Okay, just read few points. Base station with antenna arrays facilitate various MIMO schemes such as beamforming, multiplexing, diversity, and interference coordination. However, the base station antenna array has remained passive and can only adjust the beam in the horizontal dimension or azimuth angle with fixed down tilt angle. It will serve only with azimuth, right? So that means it can coverage this much area. In this area, whatever users are there, they will be served by this beam. Now see how this beam is expensive for us. In this straight line, you can see this line. In this line, 4 users, 5 users, 10 users, 20 users, whatever they all will be served by the same beam. Now the issue is that if this inward beam will focus on the user which is closer to the tower, the cell edge users will not be served well. The remote users' equipments will be outside the range of radiation because it is focused over here. And if it is focused, I mean to say the inward beam will focus the remote users, then it will interfere with the adjacent cell. So these are the problems with 2D MIMO or 2D beamforming just now. So the solution is that can you do it in a horizontal and vertical directions? So the solution is over here. So you can see that this is on one line. But for these two users, the beam is not same. Different beams are there, right? Different beams are there. So, and of course, this is using higher frequency because as I told you, 3D MIMO, wave, massive MIMO, all are connected with each other. Massive MIMO or wave, then wave I am able to make a very, a thin beam, very sharp beam I can form if I am using wave. But the problem of wave is that LOS you should maintain, right? So inside office you cannot serve the users, but on outside you can serve it. So you can see that interference will reduce, and even you can accommodate one more user over here, and you can serve that. So please remember that all are connected with each other. 3D MIMO, massive MIMO, wave. Okay. So this is 3D MIMO. The benefits of 3D MIMO over 2D MIMO, you can see this is the beam, thick beam you have over here. The beam is thin, so increase signal power because over here the power will be scattered in this region, but over here power is focused. Reduce intercell interference over here, right? No overlap over here. Overlap is there over here. No overlap, and serve more number of user equipments. Okay, the beam is very sharp, so it can use many users without introducing any interference between users. Massive MIMO, which is connected with 3D MIMO over here. This first diagram is for 2D MIMO. 8 antenna ports are there, 4 blue string and 4 red string. So this is 2D MIMO. But with 3D MIMO, you can see that instead of 8 antenna ports, over here I have made 16, 32, 64. And no interference is there between two beams. So over here, highest number of users can be served. License assisted access or LA using LTE. Now, we are talking about spectrum sensing techniques because we are facing the scarcity in spectrum. If a microwave is concerned, mmWave we have a wide spectrum we can use, but there are some issues with mmWave. The issues are separate, but in microwave now the extreme range has come. But we have ISM band also, which is free band. The Wi-Fi, Bluetooth, all the services are active. So the idea is that can the license standard, LTE is the license standard. The license standard, LTE, can LTE use this unlicensed band? Unlicensed is common for all, anybody can use it. But if the unlicensed is free or if without interfering the unlicensed band, LTE can utilize the unlicensed band. Right? This scheme is also thought because unlicensed band is not active everywhere. In certain offices and certain area only it is active. So any other place you can utilize that uh, free spectrum or free band. So coexisting a licensed spectrum 700 megahertz to 2.7 gigahertz has been overcrowded with LTE and LTE Advanced. In the near future, additional licensed spectrum will not be available. Technologies such as Wi-Fi, Bluetooth, Zigbee are implemented in ISM band 2.4 gigahertz and 5 gigahertz UNII bands. The amount of readily available unlicensed spectrum is comparable to the licensed spectrum. 400 megahertz bandwidth will be available if we are using this unlicensed or ISM band. So this is known as LTE unlicensed. Wi-Fi and LTE are two different wireless systems, as you know. Wi-Fi is designed for the unlicensed bands with uncoordinated deployment. LTE is designed for the licensed spectrum with coordinated deployment. LTE is very much coordinated. Wi-Fi is haphazard or scattered form. Anytime you can transmit, anytime you can receive. If users are more, interference will be very large. Hence, the collision avoidance nature of Wi-Fi makes Wi-Fi easily affected by LTE users when sharing the same band. Thus, techniques have been proposed to enable harmonious coexistence, including channel selection, transmission power control, blank subframes, etc. etc. By exploiting the unlicensed spectrum, the licensed spectrum can be relieved and carrier aggregation. Those who are aware about it, in LTE Advanced we are using it. So what you can do, one carrier you can select from LTE and another carrier you can select from unlicensed band, right? So LTE unlicensed comes in forms such as the license assisted access. License assisted access, that means the LTE will use the unlicensed carrier for carrier aggregation. Small cell development with co-located licensed and unlicensed carriers become a perfect fit for LTE use, right? And issues with that is there. Yeah, you can see this diagram. LTE unlicensed. This is LTE tower. This is a Wi-Fi access point, right? Now this this particular ring, violet rings, is LTE Wi-Fi dual connections. This one. This user is having a dual connectivity. This will be served by this LTE base station as well as a Wi-Fi access point also. So this is a dual connectivity. But this is LTE and LTE-U. LTE-U is equivalent to Wi-Fi of LTE. LTE-LTE-U aggregation. LTE-U meaning LTE version. Access point of LTE which is active in ISM band. So this one, LTE-U access point, and this is Wi-Fi. Over here LTE access point and Wi-Fi. So this will coordinate. It will use this Wi-Fi, but see, Wi-Fi is ISM band. You cannot interfere the Wi-Fi activity in this. If the band is free, you can use it. Uh, M2M communication next is release 12 and 13. A machine type communication through cellular network is a new applications in a network world where devices such as smart power meter. We have discussed the applications, right? M2M, the electricity company will fire an SMS at certain time interval, and the GSM module which is connected at your home with the energy meter will take the readings and send it. Similarly, street lights, when to switch it on, switch it off. Cars, home electronics such as refrigerators and TVs, and to switch it on, switch it off. AC, if you are there in the house, it will be on. As soon as you are out of the house, it will be off. Surveillance cameras. Now there is important difference between D2D and M2M. Both are looking same actually. So D2D is short distance proximity connectivity services. This is long distance technology independent. This is technology dependent. So M2M, mostly this is the buzzword for IoT, where two machines will be talking. While over here, maybe a human kind is there, a human is there at one end. Beamforming, those who are aware about beamforming, in multiple antennas, we need to install a separate RF chain with each antenna. That's why installation of multiple antennas is expensive. The reason is that the cost of antenna is not much. But along with each antenna, you need to install a separate RF chain. And that's why we are using antenna selection. We need to select antenna where antennas can be more, but the RF chain are restricted. So in case of digital beamforming, you need to use separate RF chain with each antenna. But in analog beamforming, you may have smaller number of RF chain compared to antenna. So there are pros and cons of analog and digital beamforming that you can see over here. When the beamforming is digital, the degrees of freedom will be high. In case of analog, it is low. Implementation with the help of ADC DAC, analog beam forming you can implement with phase shifter. Complexity is high over here. Over here it is low. Power consumption is high, low. Cost high, low. Inter-user interference over here is low. Over here it is high. Multiple stream can be generated, only single stream. So pros and cons are that. So of course hybrid will take care about the advantages of both. There is a very nice survey articles on hybrid beamforming. Uh, NOMA schemes, non-orthogonal multiple access. When the two user signals are not orthogonal, they may interfere. Of course, it will be there. So what is to be done for it? You can see this is user 1 signal, this is user 2 signal. Base station has to transmit it, but I don't want to transmit it orthogonally. So actually I am transmitting summation of these two. S1, S2 and X I am transmitting from the transmitter. That is E node B base station. It's surprising. Okay. The data for two, two different users I'm sending at one point of time on the same resources. But at the receiver, you can take care like this. Now see this diagram. This is orthogonal multiple access, OMA, where you know this is 1 hertz suppose signal. So half of 0.5 hertz is allocated to user 1. This is user 1, this is user 2. Right? Power allocations as user 1 is closer, you will allocate smaller power to this user and you will allocate higher power to second users, right? This is OMA. But in NOMA, what happens? The full resource, 1 hertz, is given to both the users, right? Both the users. User 1 is far away, user 2 is closer. So as this user is closer, the path loss over here will be lower and path loss over here will be higher. That means the received signal strength over here will be lower, received signal strength over here will be higher. So what this eNodeB has to do, It should transmit high power for user 1 and low power for user 2 because user 2 is closer, right? High power to user 1. Now what happens? This power, high power of user 1 may interfere user 2. Of course, yes. I repeat, this is transmitting a data for user 1 and user 2. User 1 is away, user 2 is closer. So timing advance and power control, this has two main things over here. As a result, high power is transmitted for user 1, lower power is transmitted to user 2. But user 2 will be affected by user 1 because I'm using NOMA. So at this moment, successive interference cancellation (SIC) is to be used. So first of all, this user 2 will detect the signal of user 1. It will detect the signal of user 1 and then it will subtract it from it. This high power interference will be detected well because it is having high power and then it will be subtracted. So remaining part will be user 2 signal. This is possible if you have non-orthogonal multiple access scheme output. Otherwise, you cannot have it. Yeah. So this is NOMA and the graph for data rate for user 1 and user 2, you can see this is orthogonal multiple access, okay, and this is NOMA. For both the users, you can increase the data rate. MM just one slide I have kept over here. Current mobile communication till 4G in microwave, that is below 6 gigahertz. MM is between 30 to, I mean to say, in between 30 to 300 gigahertz. Large spectrum is not utilized. So the advantage of MM is high frequency to reduce antenna size. Massive MIMO is possible because antenna size is reduced. More antennas, high path loss. The red text is not favorable text. High path loss, penetration loss, rain fading, absorption by gas, LOS you need to maintain, right? Indoor short range because absorption, backhaul, ecocell. So all these are pros and cons. Just now I told you that we are using wave, then in particular area, number of inode base will be higher than number of users. Massive MIMO, to improve the energy efficiency, the network topology must be densified to enable higher spatial reuse. Massive MIMO, right? Many beams it can generate and many users can be served. If you are using thousands of antenna, where you you don't have to increase the power, you don't have to increase the higher spectrum even. So massive MIMO has many advantages, but as I told you, this massive MIMO is to be operated on wave, and there are issues with waves. So small cell network, useful with TDD due to constant. Okay, useful in wave. About multi-user MIMO, I have told you. I'm just skipping this slide. Cognitive radio, I have explained about it. Hybrid network consisting of cellular and satellite, both are having pros and cons. Satellite has a wide coverage but higher delay. Satellite receiver is bulky, requires high power. I hope I am audible.
Yes, sir.
Okay, thank you. In satellite network, LOS is required. In cellular, it is not required. So just accommodation of both will help us to, gain the advantages of it. Hybrid network is design which exploits this. I'm going faster because cellular IoT. Have you implemented a project on IoT, your students? You just check it. Easily you can do because Raspberry Pi is very common now. Agriculture sensors are there. The students are the GSM modules are very low cost. Easily you can connect it, and obviously all of you can perform the experiment for IoT. What is the toughest section in IoT? That is wireless connectivity. Sensors and accumulation of data, compilation of data is not a big issue. But the big issue is wireless connectivity. So types of wireless connectivity are two. Either you can use the dedicated one, that is new one, or you can use the existing one, that is cellular, Wi-Fi, Bluetooth, etc., etc. Short distance and the long distance. Short distance in the sense of Bluetooth and Wi-Fi you can use. For a longer, you need to use cellular. Outline what is IoT, challenges in IoT, IoT requirement, and the massive and critical IoT. These are two important things. Massive IoT meaning many number of sensors are available, and critical IoT in the sense it should be very real time. The time delay is not permitted at all. Communication networks for IoT, we have seen about cellular standard 3G, 4G, etc., etc. But for cellular IoT, we have NB-IoT, narrowband IoT, LTE-M, and extended coverage GSM. These are the standard for cellular IoT. Cellular IoTs are used for long-range communications, not for short. For short, you can use ZigBee, Wi-Fi, and others. What is IoT? I will not go in depth of it. I think all of you are aware. M2M communication is most important. One machine to another machine. Uh, IoT system includes three domains. Mainly, you need to think about three domains. One is the device domain, second is the network domain, and third one is the where you want to use it, application domain. So, how you want to connect M to M. The network domain, a large number of heterogeneous access points are there, and network has to control all. Application wise, traffic control, traffic navigation, and smart road or smart city projects. The logistic area where cargo tracking, machine monitoring, business area, home area where healthcare, smart grid, home surveillance, etc., etc. So according to these domains, you need to design your IoT. Challenges, of course, you can go through it. Interference, channel multipath fading is always problem in wireless communication. Resource constraint, bandwidth is low, the sensor cannot get continuous power, it is having battery, computational restriction, storage restriction, heterogeneity in the devices, they are not of same type. Self-organization, QS, security, IoT requirement. As I told you, the passive and the critical IoT. One slide I want to show you. Yes, massive IoT, large number of sensors, smart building, the logistic tracking and fleet management, capillary network, smart agriculture, smart metering, and this is critical where remote healthcare or surgery is required. Traffic safety, this is critical one. Smart grid, industrial applications and control. Cellular communication network for IoT, short range, wider range. Sigfox and LoRa are used for a wider range. Wireless connectivity in license band, that is GSM, WCDMA, LTE, and future 5G are evolved for IoT. Advantages, disadvantages of cellular networks, cellular LP1 solution. These three are the standards which are used. ECGSM, extended coverage GSM. This is just our older GSM. I have already given you the example of Surat city. Thus the GSM is able to electricity meter reading, GSM, and many more applications. LTEM, which has been connected with LTE standard, then the narrowband IoT, which is also connected with LTE. So you can get the many articles on this. No new carriers are required. Same as GSM, as I told you, you just need to buy a GSM module and the sensor and give the data to that. Capacity up to 50,000 devices per cell on a single transceivers you can connect. DRX, because you need to save the power, so it should not continuously transmit the power. So discontinuous reception is that. So you can extend the battery life. This is most important things. And the LTE, it has a concern with LTE. I want to show diagram. Just go through it. Simple slides are there. In addition to LTM, NB-IoT. So LTM and NB-IoT both are used in LTE M band. So in GSM, these are the sub-carriers standalone. Any carrier you can use for it. In LTE, the guard band. Okay, in between two LTE carriers, you are having a guard band. This guard band you can use for IoT applications. While it could be part of a LTE carrier also. So I think that's all future work. So body area, then network, energy harvesting is a very important topic because the IoT, when you cannot feed power, when you cannot continuously feed the power to sensors, you can harvest the energy from the electromagnetic radiation. And the wireless information and power transfer and various projects based on IoT. I think this is my last slide. Thank you so much. Thank you so much. Yes, that's all from my end.
Thank you so much, sir. Really, your session is very wonderful and informative. Dear participants, if any query, you can write in a chat box. Any query from participant side? Okay, sir. Once again, thank you so much.
You are welcome. Thank you so much.
Kindly open your camera for a group photograph. Switch on your camera, please. Yogesh, sir. Yeah. Thank you, everyone.
Thank
And
you.
again, meet in session 3 at 2 p.m. And attendance link is open for 30 minutes. So mark your attendance for session 2, right? Thank you, everyone.